Skywarden, the aerial drone notification system, is sponsored by the Autonomous Robots Lab at the University of Nevada, Reno. The Aerial Drone Notification System, or ADNS, is an aerial drone alert and notification system which wirelessly streams drone battery voltage and the drone's proximity to obstacles in the environment to the drone operators. The system issues visual and audible alerts to the operators and sends the data over the network through the Robot Operating System, or ROS, in order to ensure safe and efficient drone operation. Shown here is a mock-up of a quadcopter body along with the wiring harness connecting the LiDAR time-of-flight sensor array, consisting of a total of 14 time-of-flight sensors, to the Teensy microcontroller. A 9-volt battery stands in for the drone battery, which is connected to a voltage sensor. Battery voltage and proximity data from the time-of-flight sensors are sent wirelessly from the drone via an RF transceiver. Shown here is another RF transceiver which receives the data sent from the drone to be used in the ground base unit. The ground base unit is a physical device which receives the data streaming from the drone, sends it to the drone operators through ROS, and issues the visual and audible alerts if voltage or proximity values are below threshold. The GUI application is shown here, with the voltage value being streamed in from the drone and displayed in the voltage text field. The voltage is also displayed on a 7-segment on the ground base unit. The user can open the Set Thresholds window in the Alerts drop-down menu. The threshold for the voltage can be set. If the voltage is below threshold, as shown here, the LED for the alert is activated and the color of the main window in the GUI application changes to red. The voltage threshold can be reset with the reset button on the ground base unit. The voltage threshold can also be lowered in the Set Thresholds window, which deactivates the alert in the main window. The proximity threshold is shown in the ground base unit. In the Set Thresholds window, the proximity value can be changed. Here it's being changed to 1, 2, 3, 4. The change of the threshold is reflected in the 7-segment display on the ground base unit, and this causes the alert to be activated in both the ground base unit and the main window of the GUI, as some of the values streaming in from the drone are below threshold. The alert can be reset on the ground base unit, and the threshold can be set back to 9999. This also causes the alert to be deactivated in the main window of the GUI. Next, we see 8 LEDs which are tied to generic alerts. This allows for more sensors to be added in the future. In addition to generic alerts which the ground unit can subscribe to, the ground unit can also publish generic alerts through switches. Here we see 2 switches being activated and their values streamed out through ROS, which is shown here in terminal. The generic switches can also be deactivated. In addition to sending and receiving generic alerts through ROS, ADNS also sends the voltage and proximity values through ROS, as shown here. The user can also open the set quaternion data in the GUI. This allows the X, Y, and Z position of each time-of-flight sensor on the drone as well as its pitch, roll, and yaw to be specified, which allows ADNS to publish the rotation and translation of each sensor as a static transform. This allows the proximity data to be visualized as vectors coming off of the drone arms in a program called RViz. RViz is also run in ROS and is shown here, along with video of a drone flying in the drone arena.